Hey everyone.
My screen is visible, Soumya?
Yeah. You can just go to the present mode. Hey everyone. So welcome to the Mutation for Gurgaon. We'll be presenting a talk on mutation testing. Before that, just a brief introduction about ourselves. I'm Soumyabrata. I have been working as a QA for about 7+ years now. And currently I'm working as a senior con QA in ThoughtWorks.
Hey everyone, Jyoti here, and I'm part of ThoughtWorks from around 2 years as a QA consultant.
All right. So with that, let's first take a look at the topics that we have for today. Yep. So firstly, we have a couple of slides to establish the need for mutation testing, and you all must be wondering, what is this mutation testing? Why do we need it? So we have some slides to understand that need. Then we will discuss, what is mutation in general terms. And post that, we will take a deep dive into mutation testing. We will also discuss one of the tools through which you can achieve mutation testing in an automated manner, and we have a demo for that as well. We will be also covering the mutation test coverage report and how you can analyze that and improve your mutation score. Also, in the end, we would highlight a few things that you can consider when you are going for mutation testing of large enterprise code bases. So with that, we would like to run a short poll. Arihant, if you can quickly launch the first poll. Yep. So how do you measure code quality? It could be any of these, unit test, code coverage, static code analysis. So we want to know what you have used in your project.
Cool. We would be closing the poll in next 3 seconds.
Mm-hmm.
Yeah. So
All
these
right.
are the answers that we have received.
Yep. So I can see that 68% of folks have already worked with 3 of these tools, and a couple of them have worked with unit test, code coverage, and static code analysis as well. So when we think about quality of a software product as testers, what comes to our mind? Right, we write tests. So we write tests at the unit testing level, then we have service level tests, then we have UI tests, right? So as you can see, this is the test pyramid. Most of you would be aware of this. So at the very bottom of this layer, we have the unit test, which is the foundation of this pyramid, and it has the most number of tests. And if bugs are caught at this level, it is very cheaper to fix them, and you also get early feedback from this unit test. So we want to make sure that these unit tests are rock solid, right? So how do you measure the efficiency of this unit test? Code coverage is something that to some extent can give you some idea of the efficiency of these unit tests. So let's also look at the Wikipedia definition of code coverage. which says it's a measure to describe the degree to which the source code of a program is tested by a particular test suite. A program with high code coverage has been more thoroughly tested and has a lower chance of containing software bugs than a program with low code coverage, right? But we beg to differ a bit from this statement. And what we are proposing is that, what we are saying is that the source code of a program, the code coverage will tell you the degree to which the source code of your program is executed and not tested, right? To understand that, you can think of any code coverage tool like Jacoco. How does it work? So what it will do is it will run your unit tests against the source code, and it will keep a track of each line of that source code, whether it has been hit at least one when your unit tests are executing, right? So it gives you an idea of the extent of execution of your source code, and not the extent of how much source code is tested by your unit tests, or how good are the unit tests, right? So you can execute 100% of your source code, you can have 100% coverage, but essentially you can be testing nothing. We can just look at the next example. We have a max calculator class, right? And within that, you have a static method, which is your find max method. It returns an integer value. So what it does is it will accept an array of integers, and from that it will return the integer with the max value. It's a plain, simple, straightforward program. Now, to test this particular method, we have written a couple of tests. So if you can see, we have considered a positive scenario with positive numbers. Then we are also checking for negative numbers, an array with negative numbers, and then we are also checking for an empty array, right? Now, if I run this program, I will be getting 100% coverage. If I go ahead and run these 3 tests, it will give me 100% code coverage. But there is something grossly wrong with these tests. So can you folks identify that and ping in the chat? Okay, I do see one answer. Anyone else? All right. So yeah, Gautam has correctly pointed out, we are missing the assert statements in these tests, right? So you don't have any assertion. So you will get 100% code coverage, but you are not actually asserting the values here, what you are getting from this method. And if you merely rely on the static code analysis tools or the code coverage tools, they don't have the power to point these fallacies, right? So you can have missed assertions. You might also forget to form all the test scenarios in your unit tests, right? But your code coverage tools cannot point that out, right? So you are getting a false sense of safety that you have 100% coverage, but your unit tests are actually not doing any testing, right? Yeah, so this is what we had missed, assert equals statement, right? And if you are running your code coverage and your unit test, it will just run fine. There won't be any error or anything pointed out. Now let's look at this funny write-up that is there, which says that good tests are supposed to fail, right? So there was this person who went to the master programmer and he was like, all my tests are passing all the time. Don't I deserve a raise? the master slapped that particular person, and he said, if all your tests are passing all the time, you need to write better tests, right? And this is a very valid scenario, right? As testers, we are writing these tests so that they can fail and catch errors. If we are merely happy with our tests passing all the time, then we don't know how well they can detect the bugs when they are actually introduced to the code. So our goal should be to write better tests which can catch the actual bugs when they are introduced into the source code. All right. So now let's talk about what is mutation in general terms. So I'm sure we must have studied this term in our school life in biology. And if we look at the current COVID situation, you have seen that every now and then we get a new variant, new mutant of the coronavirus, right? So how does that actually happen, and how you can detect that, right? So you have the parental strain of the COVID virus SARS-CoV-2. It undergoes some change in RNA, or you can also consider it that there is some modification to the genetic code of the particular virus, which gives birth to a new strain, right? So now, how you detect these new strains? You have your regular tests, and fortunately enough, these regular tests can also detect most of the new strains that come up in most cases. But consider this hypothetical situation where you have this brand new variant of COVID virus that has come up, and since you have no control over how the virus is going to mutate and what are the new mutants that are going to come up, the tests end up giving you a false negative, right? And you go for the test, you come back with a false negative, but you are still down with COVID. So that can be a very fatal situation, right? If the test is not able to detect your new strain. So taking that analogy to the software domain, if you think about software products, we have much better control over the source code. We don't have any control over the genetic code of our of the viruses, but we do have much better control over the source code of our software programs. And when I say better control, I mean by that is you can inject faults into the source code to create such mutants in advance, right? So you can have these variants or these mutants simulated in advance, and then you can run your tests against those mutants to find out the efficiency of your tests, right? So with that, we can move to the next slide.
Okay. Thanks, Soumya. Now we can have a discussion on the mutation testing. Can we have a quick poll on the audience that how much folks are aware of the mutation testing?
Okay, we would be waiting for 10 more seconds.
Yeah.
Thank you, folks.
Okay. Okay, I can't see the polls result. Maybe Soumya, you can check.
Yeah, it's visible on our screens.
Cool. So mutation testing is basically a kind of testing where we will mutate our original program so that we can validate is our test case is that good enough to capture your bug in your source code, right? So we can say the goal of your mutation testing would find the effectiveness of your test case. That would that be able to check any kind of changes or bugs in your source code, right? So that's what the definition says. We will inject some faults or some mutations, okay, into your code, and then we will execute all our tests, and we'll check if your test is getting failed. That means the mutant is killed. If your test is getting passed, that means your mutant is getting alive. Now, what is mutant? So, mutant you can consider as a syntactic change in your source code, which so we can say like each mutant will vary from your original program in one mutation. We will discuss about the mutation, how you can create different kind of mutants. We will discuss that after that. So what are the steps of executing the mutation testing, right? So the very first step, you can say, you will create your mutants, okay? So these mutants, as I said, it will vary by one kind of mutation, right? And after that, you will execute all your tests onto your mutants, whatever you have created, and you will compare the result of the test result with your original program and against your mutant version, right? So there could be two possibility. Either your test result of the original program and of the mutant version is same, right? That means we have to look at our test case again, that how we can kill our mutant, okay? What if your test result of your original program and your mutant version is different? That means your mutant is getting a killed, right? And your test is getting failed, right? So we can say that your test is good enough right now so to kill your mutants. You can measure your mutations score as well, right? So so the quality of your test can be gauged from the percentage of your mutations being killed. So that's something the formula is available for us. You can give the killed mutant counts out of the total number of mutants you have created into 100, right? So let's take an example and try to understand. There is one class, let's say a division class, where we have one function, let's say get values, right? So it is taking two parameters A and B, and it is returning some array, integer array, okay? And inside that function, what we are doing is we are calculating the quotient and the remainder, okay? And those values we are just returning within the function. And we also have a check on the divisor. If it's a 0, then we are returning a null. Okay, so we have written one unit test for this function, right? So we are calling this function with some test data 1, 1, and we are asserting those values over here. So one by one, we are getting 1 as a quotient, and the remainder will be 0 for us, right? Now let's consider a scenario on your source code. Developer has come and unintentionally he has made some changes in the operator. So it by mistake would be instead of division, we are start doing the multiplication operator. So what will happen? Will our test have that fault detection capability? For that, Aryan, we can have a poll. We can have input from the audience.
So folks, you can just take a look at the input values that we are using. That should give you an idea about how this test should perform when the division operator is replaced with the multiplication operator.
I would be sharing the results now.
Are you able to see the results, Jyoti?
No, Soumya, you have
Okay.
to call it out.
Okay. Okay. All right. So 35% people say yes, and 65% of the folks have answered no,
Yeah.
that this test does not have the fault detection capability.
Yeah, I think most of the peoples are correct because the issue we have is the test data we have selected, right? So this is a very good use case we can consider for the mutation testing, right? So if you see here, we are creating a mutant of our function, right? In that case, if we will proceed in the mutation testing, you will consider that we will get an early feedback that this test we need to have a reload, because one of the mutant creation is still getting survived, right? Okay, so over to you, Soumya.
Yeah. Yeah. So before I start with the next slide, just a quick example. So let's say you have a watchman in your building, and that watchman is not performing his duties correctly. There are lots of theft happening in the society. So what, as a society, as a committee, what would you do? Would you hire a new watchman to check and keep an eye on the existing watchman? I mean, you can surely go for that if you have budgets, but that is not an ideal solution, right? Because the new watchman you hire to keep an eye on the existing one, he or she might also be not performing the duties correctly. Instead, what you can do is you can stage some fake crimes in your society and check whether the current existing watchman is able to detect those fake crimes at the right time or not, right? So that is exactly what we do with mutation testing. If we talk about the mutation testing tools, firstly, I would like to run a poll through you all to understand if you have worked with any of the existing mutation testing tools. So we have PITest, Jumble, Striker, Jester. Do you have any experience with any of these tools? Do we have the results? Yep. So I think few of the folks, very few of them have worked with PITest, and some of them have already worked with Striker. So we at least have a few folks in the audience who have earlier worked with mutation testing, right? All right. So firstly, there is no single tool in the mutation testing space which will work across all the languages, right? And if your choice of language is C Sharp or Scala or JavaScript, you can go for the Striker tool. It is a very popular tool for mutation testing. But if your if your choice of language is Java, there are actually a couple of tools available: PITest, Jumble, Jester, Java Launch. But of these tools, only PITest is the one which is actively developed and supported, and it has a very good community base. Even in Stack Overflow, you can find the creator himself answering questions on PITest. Also, aside this factor, PITest has certain optimizations in place which has considerably reduced the execution time for mutation testing, right? So for today's purpose of demo, we would be moving ahead with the PITest tool, and we'll discuss how we can achieve mutation testing with PITest. Also, just before that, why do we actually need a tool for mutation testing, right? We have now understood a bit about the concept of mutation testing, how we can introduce faults into the code and run the unit tests against them to check if our tests are still passing or not. So if you have a very small code base, you can go ahead and generate those mutant versions of your code base manually. So as Jyoti showed you in the previous example, a division operator got modified to a multiplication operator. You can simulate such modifications in the source code manually, and then run your unit test against those mutant version of the source code. But at an enterprise level, if you do this manually, it is going to take a lot of time, right? Time and effort. So that is the reason we have these tools for mutation testing. Back in 1971, when Richard Lipton actually proposed mutation testing, there were no such tools which could actually do the mutation testing in an automated manner. And also it required massive computational power to generate the mutants and then run your unit test against the mutants, right? So with the modern availability of massive computation power, you already have the ability to do mutation testing, which has also led to wider adoption of mutation testing. So what is PIT? It is nothing but a state-of-the-art mutation testing system, which will provide gold standard test coverage for Java and the JVM. It is very fast, scalable, and integrates with the modern test and build tooling. So why do we say gold standard test coverage here? And what do we mean by that? So PIT will not only give you the code coverage, it will also give you the mutation score or mutation coverage, which Jyoti was talking about in one of the previous slides, which is your total number of killed mutants by the total number of mutants that were generated into 100, right? So both of this coverage metric will be given by your PIT report. Also, it is integrated with any of the modern build tools like Ant, Maven, and Gradle. PITest was also listed in TechRadar. I think it was listed first in October 2016, and then it has, back then it was in the assess quadrant, and now it has, in October 2020, it has moved to the trial quadrant. Jyoti, if you can just navigate to this link. Yeah.
Okay, just give me a second. Yeah.
Mm-hmm. Yep. So this is the ThoughtWorks Tech Radar for PITs, and in this you can see that PITest in the latest October 2020. This is the last status of PIT, where it had moved to the trial quadrant, and with the widespread adoption of mutation testing, we are really hoping that soon it would move to the adopt quadrant as well, right? Now we can just move back to the slides. Yep. So let's talk about how PIT works, or in general, how a mutation testing system would work. Yeah. All right. So majorly what happens is, firstly, you have to generate the mutant version of your source code, right? So there is this mutant generation step, and how you can do that, you can directly go to the source code and modify it to generate the mutants. As we saw, you can replace any of the operators as such. And the other way is to, you can go and modify the bytecode. Obviously you can't do that, but PIT has the ability to directly go and modify the bytecode which is generated after compilation, and then it will run the designated unit test against the mutated version of your source code. And since it directly modifies the bytecode which is generated, it is much faster than the other mutation testing tools that are there for Java, right? So first we have the mutant generation step where PIT is modifying the generated bytecode to create the mutants. Then you have a test selection phase where of all the unit tests that you have decided to run, of all those tests, PIT will select some tests to run against the mutants. We'll also talk about what criteria it uses to select the tests in the next slide. And then we also have the mutant insertion phase where these created mutants in the bytecode, those are again loaded back to the JVM, right? So in this step also PIT has certain optimization. It uses the instrumentation API provided by Java to load the mutants into the JVM, and that's why it is again much faster than the other tools. The last step is the mutant detection phase where these tests are run against the mutant, and we see that if the tests are passing or failing. If the test is actually able to detect the fault, it will end up failing, and we would say the mutant is killed. If the test is not able to detect the fault in the code and it ends up passing, the mutant will survive, right? Now let's talk about a few advantages of PIT. We have covered a few of these in the earlier slides. So it is definitely fast. It can analyze in minutes what would take your earlier systems days, and it's very easy to use. It can be integrated, with Maven Gradle and through the configuration. So we will discuss that in the demo as well. It's actively developed and supported. Test framework support again is something which only PIT has for TestNG. So PIT is integrated with both JUnit and TestNG. No other Java-based mutation testing framework has support for TestNG, right? Again, if you work with unit test, you definitely would be working with some of the mocking frameworks like EasyMock or Mockito, and PIT is compatible with all of these major mocking frameworks, right? Now, we talked about the mutant detection phase, right? And early exit is again one of the criteria that PIT uses to optimize its execution time. So what happens is when your test methods are running against a particular mutated version of the source code, if one of the test method fails, PIT will skip the execution of other step methods. So it will not blindly execute all the test methods that are present for that particular mutant. If one of your test method fail, that means your test suite is able to identify the fault in the code, and it should stop execution. So that is the ideal way, and PIT has done that optimization to reduce the execution time. Also, there is coverage-based test selection. So when tests are selected to run against a particular mutant, only those unit tests are selected which are covering or executing that particular line of mutated code. So let's say there's one line where your operator is getting changed, or maybe some other modification, maybe you are removing one line of code. So only those unit tests which are covering or executing that particular line, only those tests will be selected to run against that particular mutant. So this is also called coverage-based test selection, which PIT is using to again optimize the execution time. All right. So we have now talked about how PIT is the entire process that PIT uses to achieve mutation testing. But how will it actually do those mutations, right? It would definitely require some tool to do such mutations. And how will PIT know that what are the mutations that it is going to make in the code, right? So mutators, for that purpose, we have the mutators. Mutators are nothing but you can think of it as a weapon for the PIT tool to introduce mutations to your source code. And these are the default mutators that are available with PIT, and PIT has a very good documentation of all of these mutators that are available. You can go through that, but for the purpose of today's demo, we will be walking you through some of these, and even in the demo, we will walk you through some of these mutators. So let's look at the first mutator. This is an increment mutator, and it's very easy to enable or disable these mutators in the code, right? You can just go to your pom.xml and enable these mutators or disable the mutator. We'll discuss that in the demo. For now, let's just understand what the mutator will do. So if I'm enabling the increment mutator, it will mutate all the increments and decrement statements of the local variables. So if you see here in my source code, if I had I++, that would be mutated to I minus minus automatically. You don't have to do anything. You just have to configure this increment mutator in your configuration, POM configuration, right? And if we go to the next mutator, which is our void method called mutator. Now, again, if we talk about void methods, they don't have a return type, right? They don't return anything. So essentially, how do you, do the unit testing of void methods, right? You don't have any returned value to perform some assertion on, right? So how void methods are unit tested is basically if you have a void method, it will have some side effects, right? So those side effects need to be asserted. And if you have missed asserting the side effects of the void method, then this mutant, if you are using this mutant, those kinds of errors will be caught in this mutation execution. So it will highlight such variable scoping issues, and also if you are not asserting the side effects of void method. And what it does is simply, if you have a method I, which is a void method, it will simply remove the call to that particular void method, right? So in case you didn't have any assertion on that void method, your test will, pass. All right. So let's move to the next mutator, which is the negate mutator. Again, it's a straightforward mutator. You have, if you have something like A equals B, that will be mutated to A not equals B. So this condition will be reversed, and vice versa. If you had the not equals B, it would be mutated to equals. So these are the kind of mutators that PIT has, and you can go through the documentation of PIT itself to understand the different variations that are there for each mutator. Now we will be moving forward with the PITest tool setup and demo. If we can quickly, yep. So we have a matchmaker class, and the responsibility of this matchmaker is to take a person. That person can be male or female. It's a we have created a enum, and it will accept only male or female values, and the matchmaker is responsible to marry them, obviously. But first it will check the eligibility of that person for marriage, right? So if the gender is female and the age is greater than equal to 18, then it will be then that person will be eligible for marriage. And if the gender is male or female and age is greater than equal to 21, then also the person is going to be eligible for marriage. So it's a simple class with one method is eligible for marriage, and it has a enum. To test this out, we have written a couple of unit tests. If you can see here, we have taken the age. So for male, we saw that the age restriction is 21, greater than equal to 21 should be eligible for marriage. For female, the age restriction is 18, greater than equal to 18 should be eligible. So we are simply going ahead and testing with 22 and 19. So since I am using 22, of course, I should get a positive value, a true value, and that's why I'm asserting with true. And similarly for the female gender, I have set it to 19, and then I'm asserting it as true, right? Now Jyoti will actually walk you through how you can run these tests and get the mutation coverage for these tests, and how you can also integrate PITest with the Maven tool and improve your mutation score. Yeah, over to you, Jyoti.
Thanks, Soumya. So we can see firstly the setup of PITest, how we can set up in the code base. So as we discuss about it support multiple build tools, like you can do on Maven, Gradle, even some of the IDs also provide the plugins for the PITest, like Eclipse ID and IntelliJ, and there is also an Antas you can integrate, right? So for example, for the demo purpose, we have taken, let's say, the Maven build tool, and we have written the form XML file, and you can see that how you can integrate your PITest, how and what are the dependencies we require. So here you can see, okay, so here in the plugins, if you see, we have added the artifacts for the PITest, right? And on the dependencies, if you see, we have added for the JUnit 5, the artifacts of the PITest JUnit 5 plugin, right? So we need to take care about the versions. So here currently we are using a JUnit 5 version. Definitely that PITest dependency should be compatible with your JUnit, what versions you want to consume, right? And there is a very well blogs available. You can check it out, how you can integrate those dependencies, version compatibility, right? Okay. Then after that, there are a lot of configurations also available for the PITest tool that you can consume, right? We try to accommodate as much configurations, but yes, there is in a documentation, you can see a lot of configurations you can explore, right? So for example, you can target your classes, right? For which you want to create the mutants. Okay. So I don't want to do mutation testing for, let's say, the modal classes, right? I don't want to do for DB connections files. So you can just add on those packages over here, right? Then the report directory. Yes, we are using, let's say, the build directory, and after that I want it in my PIT reports. I can configure that. Then we have the output formats. Okay, so on output format, it support multiple extensions, right? So there can be a use case. If you see the HTML formatting, it will be the decent report PITest provide to us. Let's say if you want to integrate with some code quality assurance tool like SonarQube, right? So that requires an input of XML file of the PITest report, right? So you can consume that XML file over there and put on the quality gate checks on which mutation score you want to have a check, right? So you can consume different formats over there. Then yes, we can exclude the classes here. What packages you want to exclude? Yeah. Then we have threads configuration. Okay, so you can't. So the default value of this thread is 1, and this threading will help you to speed up your execution of your mutation testing. And this threading will help you to create the mutants of your classes using these thread counts. right? So we have added, let's say, the 4. Yes, then we have a target test. Okay, I want to run some of the test only against those mutant creations. So I can do that selective things over here. Then we have a timestamp report. Yeah, if you need, if you want to maintain the history of your reports for analysis, you can mark it true. And for now, we are just have given false right now. Okay, then these are the mutators. So these are the mutators. Depending on the nature of your project, you can choose your mutators on which mutator you want to create the mutants, right? So instead of giving the mutators separately, you can also use the groups of mutators. So, like the default group mutator, some more groups are available, so you can consume that as well. Okay, that is something on the configuration side. Uh, now let's run our mutation test. So yeah, so currently here we are trying to run all the unit tests and our mutant test as well with the mutation coverage. So if I execute this command, okay, so if I go to the report, okay, so this is the report being created on our 2 tests that we have executed. And for that, how much mutants are being created. So as you can see, it gives you a very basic and decent details. You can see the packages. And on these packages, what are the classes available to you for creating your mutants, right? So here you can see the number of classes I have one, the line coverage it provides me, and the mutation coverage as well, right? So this count, you can see it is giving my line coverage counts, and it is giving me a count of the mutants being created, right? So here 5 out of 7 means 5 are being killed, and 7 and out of 7, and 2 will be the one which is getting survived. So if I click on my Java class here, okay. So in this class, you can see this light green color highlighted lines, right? This is giving me something, my code coverage, right? And here, if you see this dark green one, here on the hover, it will give me a mutants, like how many mutants are being created for my this line, right? So it is saying the gated condition is killed, right? So we have integrated the negated conditional mutator, right? So if you see this negate condition mutator, I'll show you here. So in the documentation, they try to give all the scenarios and different data types, what kind of mutants will get created. Go to the negate one, this one. Yeah. So if you see on these operators, it is trying to create, it will try to create this kind of mutator operator. So yeah. So here on equal, it will try to negate this condition, right? So if I go to my test back, my test is make a test. Yeah. So there is one test we have written for test where we are passing the age 19, we are passing the gender as a female, right? So on negating this condition, it will directly give me a goes to this condition, right? This else condition. And in that condition, the 19 will always be greater than 21. So this condition will get false, right? So this test will automatically get false. right? So that's the reason this mutant is being killed in this case, right? So if we say some survived case, let's say, right? For this line number 10, if you see, there are 3 mutants are being created. Okay. So the very first one, if you see, there is one conditional boundary which is getting survived, right? So in this condition, the conditional boundary mutator, what will it do? It will try to change this greater than equal to the greater one, right? So if I show you on the documentation, so you see, so these kind of mutants will get created for this condition. So in our case, let's say the greater than equal to will be mutated to, let's say, greater than, right? So in that case, what will happen to our test? So in our test, this 90 is still greater than 18, right? So our test will still get a pass, right? So that means our mutant is getting survived in that case, right? Okay, so if you see the next one, that is the negated condition which is killed. Okay, so the negated condition, as we see, this condition will get negated, right? In that case, your 19 is less than 18, which is false, right? So that means your test will get false, right? So that's the reason is your mutant is getting killed in that case. If you see the third one, if you it says for replace return of integer size value. Okay, so what this mutator is, this is your return vals mutator. Okay, so if you try to see here, yeah, so this mutator is basically for different return type, it tried to create the mutant. Let's say for the Boolean, it will give you true with the false and a vice versa for that. And for the int byte, let's say it makes this 0 to 1 or 1 to 0. Similarly, if you see for the long one, x, it will give some x plus 1 value, right? So in the similar way, what it tries to explain is it replaces your integer size value with 0 to 1. That means your condition is your return value is getting replaced by that. So in that case, again, your test is getting failed because you are validating it with your 90 as an age and female as a gender, right? If you see on another line, similar kind of mutant is getting created over here as well. This is the use case for your male test case, where we are passing the age as a 22 and the gender as a male, right? So in this case, the very first mutant is created for the conditional boundary, right? So that's what we discussed. Like this greater than equals to will be changes to your greater than, and the test data what we have selected is 22. So that means your test will still get passed in that mutant, right? And similar for the second one, third one, if you see the negated condition is getting killed in that case, and replace return of integer size value is also killed in your case. Cool. So this is the more described we try to tell the line number, on which line number what kind of mutants are being created, and the number of counts of those mutants as well, right? And it will give you the active mutators, what are the mutators being injected in your source code, and what are the tests being examined. So these are the tests we are executing against our all the mutants that we have created, right? So if I go to the branch where we have fixed improve our test, yeah. So here we try to cover all other scenarios, right? So if you see here, the very first thing is the negated. We haven't validated the false conditions here. We were validating only the happy scenarios here, right? So that thing we have covered, and all the conditional boundary values as well is also incorporated here with all conditional test data. So for the main, we have a condition. We have a condition on 21, right? So that test data we have covered here for the male gender, the 20, 21, 22, and similar for the female as well, if you see. So the 17, 18, 19, and what will be the return type for that case, right? And here we are also adding another scenarios. Let's say if you're not passing your gender, then in that case for 17, 18, 9, 17, 18, 20, 21, 22, what will be the return values in your case, right? If I try to run now this test, let me refresh this one. Yeah, so there will be the mutation coverage it is giving, right? We try to cover all the conditional values, we try to cover all the negative scenarios, and it gives you that mutation coverage as well, right? Okay, so let's go back to our slides. Okay, so there are some points we can take care in a enterprise level code base that would help you to take more benefit of your mutation testing. Is firstly, you can limit your mutators and mutations. So depending on the nature of your project, what kind of mutators you want to inject. We can't blindly go with all the mutators, right? So that we can limit at our testing. The second one is saying set target exclude classes, test in build configuration. Yeah, so that is the capability being provided from the PITest tool, that you can limit your what classes you want to mutate and what tests you want to execute against those mutate. We can control that, right? Then we have use threads to speed up execution. Yeah. So initially, because of the computation constraints, that mutation testing takes a lot of time, but now definitely these are the capabilities being provided by the PITest. You can control the thread count for creating your mutants. Okay. You can adopt strategies from the following. Okay. So mutation testing, there are some strategies that we can take care of while executing the mutation testing. We can plan some kind of workshops internally our project for doing the mutation testing, right? Let's say if we come with some new feature build, right? So we can do that mutation testing at that point of time, and that will help you to find out the effectiveness of your test and where you can do more optimization. Yeah, we can control it by a cron job, nightly builds. We can integrate with that, right? So there is one more incremental analysis for the new feature. So PITest has provided one more capability that we can leverage is for incremental analysis, where the PITest is smart enough to take care from the previous runs of your mutant test executions, right? So if I'll take an example, let's say if some mutants are survived, right, and there is no changes in your test and no changes in your class, right, in that case your mutant will still get survived in the next execution, right? So that thing we can definitely leverage of. Do not over engineer unit test to kill all mutant. Yeah, so we should not go for 100% mutation score, right? So we can as we discussed, we on the sonar cube you can put some kind of quality gates over there. We That 100% mutation score will definitely not help you, will not be that beneficial. You can go with some generic depending on your project nature. It will help you a lot with that. Okay. Okay, these are some of our references. Please go through that. If that's all.
We can have a last poll, the last one, Arihan. Yep. Just to see the response of the folks. Also, if you can share the feedback link in the chat.
Yeah, I'm doing so. People, please share your feedback on the link. And if you have any challenge in accessing it, please let me know.
So we have a very good response from the poll, 92%.